First, we learn what is plane of symmetry. A plane is an imaginary line that bisects the molecule so that each part of the molecule becomes mirror image of the other. If such imaginary line or plane is present in the molecule, then it is known as plane of symmetry. Let's take an example of water molecule. If we pass an imaginary line that passes through this oxygen atom, then this line divides this molecule into two equal parts. Therefore, this is known as plane of symmetry. We can show the same plane of symmetry in another way by passing this figure into these two hydrogen atoms. It also indicates the presence of plane of symmetry. This plane of symmetry is represented with the symbol sigma. Therefore, we can write for this diagram this sigma as a letter that indicates the presence of plane of symmetry. Let's learn this plane of symmetry with the help of this model. In this model, this is the oxygen atom. These are the hydrogen atoms. If we pass this imaginary line in between these two hydrogen atoms, then it divides this molecule into equal parts, and that equal parts are mirror images of each other. In this way, you can pass this plane of symmetry. If I hold this water molecule in this way and pass an imaginary line in between this oxygen atom and this hydrogen atoms, it also divides these three atoms into equal parts. Therefore, this is also known as the plane of symmetry. If I pass an imaginary line through these three atoms, then it also divides this molecule into equal parts, and these equal parts are mirror images of each other. Similarly, I also pass the plane through these three atoms. It also divides this molecule into two equal parts, and these two equal parts are mirror images of each other. Let's consider this third molecule. This molecule also contains plane of symmetry. If we place this imaginary line or plane through this first atom, then it divides this molecule into two equal parts, and these two equal parts are mirror images of each other. Similarly, I can pass plane through this atom. It also divides this molecule into two equal parts. This is also mirror images of each other. Similarly, you can pass plane through this atom also. It also divides this molecule into two equal parts, and that are also mirror images of each other. There are three types of plane of symmetry. First one is vertical plane of symmetry. Any plane that is parallel to the principal axis is known as vertical plane of symmetry. Then second one is horizontal plane of symmetry. Any plane that is perpendicular to the principal axis is known as horizontal plane of symmetry. Next type is dihedral plane of symmetry. Any plane of symmetry that passes in between two consecutive C2 axes, then it is known as dihedral plane of symmetry. This vertical plane of symmetry is represented with the symbol sigma V, where V stands for vertical plane of symmetry. Horizontal plane of symmetry is represented with the symbol sigma H. This H represents horizontal plane of symmetry, while this dihedral plane of symmetry is represented with the symbol sigma D, where this D represents dihedral. In this way, you can remember all these three types of plane of symmetry. In next lectures, we are going to learn all these concepts in detail. Consider the example of water molecule, where this is the oxygen atom, H1 and H2 atom. In this case, If I rotate this molecule by holding this oxygen atom, this shows the presence of principal axis. And if we pass a plane in between these two, it is also parallel to the principal axis. This plane is known as vertical plane of symmetry. Similarly, if I hold this atom in this way, and if I want to rotate this molecule with 180-degree, and if I divide with this plane is also parallel to the principal axis, and therefore it is also known as vertical plane of symmetry. It means this molecule contains two vertical plane of symmetry. First one is like this, and second one that passes through these atoms. In this molecule, C4 is the principal axis and that passes through this platinum atom. Therefore, this is known as principal axis. According to the definition of vertical plane of symmetry, it is always parallel to the principal axis. Therefore, if I pass plane through these three atoms, then it divides the molecule into equal parts and it is parallel to this principal axis. Therefore, it is known as vertical plane of symmetry. I also pass the plane from these three atoms. This is also parallel to the principal axis and therefore it is known as vertical plane of symmetry. The next one is horizontal plane of symmetry. All atoms in this case are in a one plane, therefore it is known as planar molecule, and in every planar molecule there is a presence of horizontal plane. In these planar molecules, if I pass the principal axis through this platinum atom, it means it is perpendicular to the plane, and any plane that is perpendicular to principal axis is known as molecular plane. Therefore, in this case, there is a presence of molecular plane also. If I rotate this molecule with 180-degree rotation, in this way, 180-degree rotation, it indicates the presence of C2 axis, and if I pass a plane in between this first C2 and second C2, then it divides the molecule into equal parts, and these parts are also mirror images of each other. Therefore, there is a presence of dihedral plane. If I pass a plane in between two C2 axes, then it is known as dihedral plane. Let's take an example of this BF3 molecule. In this BF3 molecule, there is a presence of C3 axis as a principal axis, and this principal axis is perpendicular to this plane. It indicates the presence of molecular plane. If I pass a plane in between these two atoms, and that includes this boron and this atom, then it divides the molecule into two equal parts that are mirror images of each other, and it is parallel to the principal axis, and therefore it is known as vertical plane. In this way, there is a presence of vertical plane. It is also parallel to the principal axis. This one also shows the presence of vertical plane of symmetry. Dihedral plane in this case is absent. In this way, you can show the presence of plane of symmetry within a molecules. Thank you.